All right, let's talk about C++ variables. Now, I know what you're thinking. Variables, that's like day one stuff. But here's the thing. In modern C++, how we handle something this fundamental has huge implications for writing cleaner, safer, and way more efficient code. This isn't just a refresher. It's about upgrading your entire C++ mindset. So let's just cut right to the chase with this one question. When you initialize a variable, are you using parentheses or are you using curly braces? Your answer, believe it or not, says a lot about how you approach modern C++. It seems like such a tiny detail, but this choice is at the very heart of a major shift in the language. Okay, so before we settle that debate, let's make sure we're all on the same page. Let's ground ourselves in the basics. What exactly is a variable? You know, the simplest and honestly the best way to think about it is just as a named box in your computer's memory. It's a specific spot you've set aside to store something. And here's the more official take. It's a named portion of memory used to store a value. The really crucial part here is the type, like int or double. That type is basically a set of instructions for the compiler. It tells it exactly how big that memory box needs to be and how to make sense of the zeros and ones you store inside it. Now, of course, you can't just go naming your variables whatever you want. C++ has a few simple rules you gotta follow. The name has to start with a letter or an underscore. It can't be a reserved keyword. And don't forget, C++ is case sensitive. So result with a lowercase r and result with a capital R, to the compiler, those are two totally different variables. Simple, I know, but it's a classic trip up. All right, this is where it really gets interesting. How do we put that first value into our memory box? This is what we call initialization. And over the years, C++ has given us a few different ways to do it. The one you choose actually has real consequences for your code's safety and how clear it is to read. Let's take a quick trip through history here. We started with the classic C style, just using an equal sign. Then C++ gave us constructor-style initialization with parentheses. And finally, with the C++ 11 update, we got what's called uniform initialization using these curly braces. And this is where that big debate from the beginning comes right back. 3 ways to do the exact same thing. So which one is best? Well, it turns out the modern C++ community has a pretty strong preference, and it's for a very, very good reason: safety. Let's dig into why those curly braces, that new kid on the block from C++ 11, are often considered your best friend when you're coding. And this slide right here shows the #1 reason why. Just look at the old way, with parentheses. If you try to initialize an integer x with a decimal number like 2.5, the compiler just silently chops off the decimal. Boom, x is now 2, and your data is just gone, without a single warning. But the modern way, with the curly braces, it throws up a stop sign. It sees this narrowing conversion, and it gives you a compiler error, forcing you to fix a bug before it ever even becomes a bug. That is huge. And if that wasn't enough, it also solves another infamous C++ headache, the most vexing parse. It's this weird quirk in the language's grammar, where if you write widget w, the compiler thinks you're declaring a function, not creating a variable. It's a classic trap that has tripped up developers for decades. But if you write widget w hashtag, there's no confusion. It is always a variable. Another point for curly braces. Now, hey, don't just take my word for it. This advice is echoed by the absolute experts in the field. Scott Meyer's landmark book, Effective Modern C++, dives deep into exactly these kinds of topics. It's basically the go-to guide for writing great software with modern C++. But here's what's really interesting. Even an expert like Myers admits that there's no single perfect answer. He points out that both styles have their pros and cons. So what's his ultimate advice? Pick one style, it doesn't matter if it's braces or parentheses, and just be consistent. In the end, consistency across a big project is often the most important thing. Okay, we've talked about specifying types and how to initialize them. Now let's talk about a modern C++ superpower that makes all of this even easier: the auto keyword. This thing is a game changer. It lets the compiler figure out the type of a variable for you, just based on what you initialize it with. I mean, just look at this example. Before auto, if you wanted to declare an iterator for a set of strings, my gosh, what a mouthful. It's long, it's tedious, and it's so easy to make a typo. Now, with auto, it's just auto it equals st.begin. Done. The compiler knows the type, so you don't have to spell it out. It's cleaner, it's simpler, and you're way less likely to make a mistake. But, and you know there's always a but, right? This is where things get a little tricky. This is a real modern C++ gotcha. What happens when we combine our new favorite keyword, auto,
with our new favorite syntax, curly braces. Specifically, this little line of code right here. Auto x equals 5.
So, take a second. What do you think the type of x is? The obvious answer seems to be int, right? I mean, it's a single number inside braces. But it's not quite that simple. And here is the surprise. The compiler doesn't deduce int. It deduces standard initializer list int. That's a special kind of type used to handle collections of values. This is a special rule you just have to know. When auto sees curly braces, it automatically thinks list, even if there's only one thing in it. It's a crucial exception to remember.
Okay, so we've covered how to declare and initialize our variables. Now let's kind of zoom out a bit. We need to understand where these variables live inside our program and for how long. And that brings us to the concepts of scope and lifetime.
Now, it's super easy to get these two mixed up, but this slide lays it out perfectly. Scope is all about visibility. It's where in your code you're allowed to use the variable's name. Lifetime, on the other hand, is about existence. It's how long that variable's memory box is actually around while the program is running. They're related, for sure, but they are not the same thing.
See, a variable's lifetime depends on where it lives in memory. Most of your variables, the ones you declare inside functions, they live on the stack. Think of the stack as super fast temporary storage. It's created automatically when a function starts, and it gets completely wiped clean the second the function ends. Then you have global and static variables. They live in a totally separate area, and they stick around for the entire life of your program. And finally, there's the heap, which is for manually managed memory, but that's a much bigger topic for another day.
And speaking of those global variables, they can get really messy really fast. Here's a great pro tip from a discussion on Reddit. To keep things organized, group your related global variables together inside a single struct. It's a simple but really effective way to clean up your code and avoid nasty naming conflicts. And this brings us to one of the most classic, most dangerous C++ mistakes you can possibly make. This is where scope and lifetime collide in the worst way. If you create a pointer to a local variable and then you try to use that pointer after the function is over, you are pointing to garbage. The variable's lifetime has ended. The memory's gone. This is a recipe for disaster. Okay, let's boil it all down. To really modernize your C++, here are the key takeaways. First, try to prefer braced curly brackets initialization for its safety features. Second, embrace auto for cleaner, clearer code, but never forget that special initializer list rule. And third, always think carefully about where you declare your variables, because that's how you control their scope and ultimately their lifetime. And that brings us to the end. We've gone all the way from the absolute basics of what a variable is to the really nuanced debates that define modern C++ development. So the final question, that's for you. Now that you know the rules, the trade-offs, and the gotchas, how are you going to write your next line of code? Thanks for joining me.